Hello students, how are you all? I hope you all are healthy and safe. So today we are going to discuss some of the examples regarding linear equations in one variable. As I've already discussed about the concept of linear equations in one variable in my previous video. So those who have not watched that video, first watch that video and then come to this video. So first of all, we are going to see some of the recap regarding the linear equations in one variable. Okay, so we are going to see what is an equation. So what is an equation, students? A statement which states that two algebraic expressions are equal is called an equation. A statement which states that two algebraic expressions are equal is called an equation. 3x square plus 5 is equals to x minus 5, 3x minus 2y is equals to 8, 6 minus x is equals to x plus 9 are all the examples of an equation. Okay, what is in variable? The most equations that we study in algebra contain variables which are symbols, usually letters that stand for numbers. Yes, in equation 4x plus 7 is equals to 19, the letter x is the variable. As we have seen, what is an variable? It is the symbol, usually letter, as x is a symbol, usually letter, which is the variable in an equation. So, as we have already seen that x is an unknown in the equation, as we don't know the value of x, and this is also the variable, so we have to find out the value of x after solving this expression. Okay, the equation involving one variable in first order is called the linear equation in one variable. Okay, what is the example? 3x minus 5 is equals to 0, 8 minus y is equals to 2, 7 plus a is equals to 15 minus 3a are the examples of linear equation in one variable. Okay, what are the properties of equality? Okay, we use the following properties to solve an equation. A, B and C stand for an algebraic expressions. The symbol this means is equivalent to. So what are the two properties that we have seen? The first property states that A is equals to B, which is equivalent to A plus C equals to B plus C. Adding the same quantity to both sides of an equation gives an equivalent equation. If you add the same quantity to both sides of an equation, we get the same equation. Okay, what is the second property? A is equals to B, which is equivalent to CA equals to CB, but C should not be equals to 0. Yes students, remember this very carefully. Multiplying both sides of an equation by the same non-zero quantity gives an equivalent equation. Okay, as we have already discussed about this example in my previous video, so we are going to see the next example. Okay students, so okay, now see the next example. So what do we have example as here? Solve x by 3 plus 5 by 2 is equals to minus 3 by 2. So we have to find the value of x, as x is the unknown in this equation, and this whole equation is the linear equation in one variable. Okay, so how you are going to solve this question? Transposing 5 by 2 to the RHS. What do you mean by transposing 5 by 2 to the RHS? It means, as we have already discussed about the statement, that to solve an equation, we solve an equation by shifting all the terms containing variable on one side and all constant terms on the other side. So after shifting all the terms containing x or variable to one side and constant terms to the other side. So how do you shift that? What is constant term here? 5 by 2 is the constant term in our equation, and minus 3 by 2 is also the constant term in our equation. So we shift 5 by 2 to the RHS, it becomes minus 5 by 2, because when you shift number from one side to another side, its sign gets reversed. So in left hand side it gets the positive sign, and after shifting it to the right hand side it comes with the negative sign. Okay, so taking the LCM as 2 as the LCM, the both numbers get added because they contains the same sign but with the minus sign in front. So it becomes minus 8 by 2, which is nothing but minus 4. Okay, so now what we are expression, x by 3 is equals to minus 4. Multiply both sides by 3 because 3 is the denominator in our expression. So we shift 3 to the right hand side. It becomes minus 4 into 3 becomes minus 12, and we get the x as equals to minus 12 as an answer. Now we are going to check whether our answer is correct or not, as I've already told you about how to check an answer. So let's see. By checking an answer, what do you mean by checking an answer? Means LHS should be equals to the RHS. Okay. So how do you check an answer? What do you have as an LHS? LHS is x by 3 plus 5 by 2. Okay, x by 3. What do you get as x? X is minus 12. So minus 12 by 3 plus 5 by 2. Okay, minus 12 by 3 can also be written as 4, as 3 4s are 12. So minus 4 plus 5 by 2. Taking LCM as 2 and multiplying 4 2s are 8. We getting 8 here. Minus 8 plus 5 becomes minus 3 by 2 as an RHS. So Rn RHS becomes minus 3 by 2 as RHS equals to LHS. So our answer x is equals to is minus 12 is correct. Okay, now see another example regarding. Solve 15 by 4 minus 7x is equals to 9 using linear equation in one variable. How you are going to solve this equation, students? Let's see. 15 by 4 minus 7x equals to 9. Using the property that we shift the constant terms on one side and containing the variables on the other side, shifting 15 by 4 to the RHS, it becomes minus 15 by 4. And when you subtract 9 minus 15 by 4, how do you solve this expression? By taking the LCM as 4. Okay, and 9 4s are 36, and minus 15, it becomes the 21. Yes, minus 7x is equals to 21 by 4. Then now as 7 is multiplied with x, now we shift 7 to the right hand side, it comes to the denominator. Okay, so 4 7s are 28. But here we have solved with another example with some using the constant as concepts, as when you divide 21, you can also write 21 as 3 into 7, 3 into 7, and 4 into 7. 7 and 7 gets cancelled. So what do you get? X as minus 3 by 4. Simple. So let's check in our answer. LHS equals to 15 by 4 minus 7x, and we get x as minus 3 by 4. After multiplying 7 with 3, it gets 21 by 4. 15 by 4 plus 21 by 4, as this minus sign and this minus sign after getting multiplied becomes positive sign. Then adding 15 by 4 plus 21 by 4, we get as 4 as the LCM. 15 and 21 gets added, it becomes 36, and 9 4s are 36. So our RHS is 9 and RHS is 9. So LHS and equals to RHS. That means our answer x is equals to minus 3 by 4 is correct. Okay, now see an question based on application regarding linear equation in one variable. 20 years ago, Anil's age was 1/3 of what it is now. What is Anil's present age? Let's understand one more time. 20 years ago. 20 years ago means 20 years before. This year is 2022. That means in previous year, 20 years ago means 2001. 2. Yes, 20 years before. Means 20 years before, Anil's age was one third of what it is now. That means what it is now in this age. So we have to tell about the Anil's present age. Okay, now let's see. We can write the given information by using a linear equation in one variable. Okay. Let let's suppose Anil's present age be x years by taking the variable x. That let's suppose Anil's present age be x years, as we don't know Anil's present age. That is the question that we have to solve. Okay. 20 years ago means 20 years before. Anil's age was x minus 20, means 20 years before his age was x minus 20. According to our question, that x minus 20 is equals to x by 3, as Anil's age was one third of what it is now 20 years before. Okay, so if Anil's present age is x years, so his one third age was 1 by 3. So 3x minus 20 equals to x. Okay, x minus 20 is equals to x by 3. After transposing 3 from right hand side to the left hand side, from denominator it comes to the numerator and becomes the multiplicative property with this expression. And when you multiply 3 to the bracket, we get 3x minus 60, 23 is 60, is equals to x. Using the property shifting the constant terms on the left hand side or right hand side and variables to the other side, we get, so what is variable here? 3x and x are the variables. So we keep 3x and x to one side and minus 60 to the other side. After shifting minus 60 to the right hand side, it becomes positive 60 plus 60, and you shift x to the left hand side, it becomes 3x minus x, it becomes 2x is equals to 60, and when you shift 2 to the right hand side, it comes to the denominator and it becomes 60 by 2, which is nothing but x equals to 30. Yes, so therefore the present age of Anil is 30 years. Okay, now let's see one more time. We can write the given information using a linear equation in one variable. Let's Anil's present age be x years. Present age of Anil is x years, as we have supposed. We can suppose x, y, z. You can take any variable. We are supposing x here. So 20 years ago, Anil's age was x minus 20, means 20 years before. If present age is x, then previous age was x minus 20. Then according to the given information, x minus 20 is equals to x by 3, as present age was one third of what it is now with the previous age. So x minus 20 is equals to x by 3 as the present age. So 3x minus 20 is equals to x. 3x minus 60 is equals to x. 3x minus x is equals to 60. 2x equals to 60. X is equals to 60 by 2, and x is equals to 30 is the present age of Anil. Okay, you all get that? Now let's see one more application based example. Soham worked as a carpenter. In the month of September, he was paid rupees 50 per day. However, 10 rupees per day was deducted for the days he remained absent. He received 900 rupees for the number of days he worked. How many days did he work? Okay, let's understand one more time. Soham, who was a carpenter, he worked in the month of September. He was paid rupees 50 per day. As you already know that September is the 9th month of the year and it has 30 days. So he was paid rupees 50 each day. Okay, and the day he remains absent, 10 rupees gets deducted from his salary per day. Okay, so he received at the end of the month 900 rupees. So we have to find out the how many days did Soham work for this 900 rupees. Okay, now let's see. Let the number of days he worked be x days. Let's suppose that Soham worked for x number of days in the whole month. Hence, the number of days he did not work will be 30 minus x. Why 30 minus x? Because September is the ninth month of the year and it has 30 days. So the day for which he does not work is 30 minus x, as he worked for x days. For day he does not work should be subtracted. He worked for x days, then the days for he does not work should be 30 minus x. So he was paid rupees 50 each day as given in the question. He worked and 10 rupees was deducted for each day he did not work. At the end of the month he received rupees 900. According to the given information, we can form a linear equation in one variable as 50x minus 300 plus 10x is equals to 900. How did you solve this expression? How did you solve? That he gets for x days, he gets for x day he get rupees 50. Okay, so 50x, so means we get, as per day he got 50 rupees, for x days he got 50 into x. And why minus 300? Because when you multiply 50 into this number you get minus 300. So 50x minus 300 plus 10x is equals to 900, forming the expression. So how you will solve this equation? By shifting the constant terms on one side and the variable containing on the other side. So the constant terms are minus 300 and 900 and the variables are 10x and 50x. After shifting minus 300 from LHS to RHS, it becomes plus 300. As you've already seen that minus sign becomes the positive sign after shifting, it gets reversed. So 50x plus 10x becomes 60x, which is 900 plus 300 and nothing but 1200. So as x is multiplying with 60, when you shift this 60 to the right hand side, it comes to the denominator. 1200 by 60, we get x as 20. So therefore Soham worked for 20 days. As we have seen that Soham worked for 20 days. So when you multiply 20 with 50, 50 20 into 100, and it becomes the 900, as he does not work for the 30 days. For the 10 days he does not work. Then 50 into 30, 53 is a 150. 150, okay. So 50x minus 300 plus 10x equals to 900. 60x is equals to 900 plus 300. X is equals to 1200 by 60. Then x equals to 20 is the number of days that Soham worked. Did you all understand completely, students? Okay. So this was in this session. Only this we are going to study. Now let's meet in the another session. Thank you and bye bye.